Today we're going to be talking about slope. So this is something that you've learned in the past, and this is something where we use the letter M for slope. There are three ways that we can kind of think about this. So if it's graphed, oftentimes you're going to think of it as rise over run. So how much you rise over how much you run. You can also think of slope as the change in the y. So when you're rising, that's the change in the y over the change in x, which is when you're going left and right, which is running. And then there's also the slope formula where we have y2 minus y1 over x2 minus x1. So first we're going to look at a few of these that have a graph, okay? So if we have a graph like this, it could be the case that the points are picked out for you. So in this case, we have these 2 points. If they don't, then you do need to find 2 points that are on the actual line, preferably ones that are on nice, easy coordinate points to help make it a lot easier for you to deal with. Another thing we got to pay attention to is what we're counting by on the x and y axis. So these ones here are counting by ones, but it could be the case that we're counting by threes on the y axis and twos on the x axis or something like that. So just be very careful. So for slope, we're going to do rise over run. We're always going to start with a left-hand point and create a triangle to the right-hand point. So we're rising, we're going up 2 spaces, and then we're running 4 spaces if you count that across, but 2/4 implies to be 1/2. Okay, so this makes sense that it should be positive because it is going uphill. Okay, again, we read graphs from left to right. So then let's take a look at this one here. So we have another graph, or another equation here. Again, we have 2 points. We're going to create a triangle. Okay, and we're going to count rise over run from the left point to the right hand point. Again, we're counting by ones on both axes, so we're good to go. Here we're going down 3, and then we're going right 12 spaces. So since both of those are divisible by 3, we would get a slope of -1/4. And again, that makes sense since we're going downhill here. Okay, let's take a look here. And with any of these, it could be the case that you are using this formula. You could figure out the coordinates of these points and do that. But if it's graphed, I honestly think that it's easier to count rise over run. Okay, and then simplify that fraction if necessary. All right, so on this one, we have our 2 points, and we can't make a triangle out of this at all. But our rise, so technically, I guess it doesn't matter if you go from bottom to top or top to bottom. So we're going to rise 6, and we're not running anything. Well, 6 divided by 0, that doesn't make sense. That's not possible to do. So here, our slope would be undefined. Okay, so if it is a line that goes straight up and down, it is a vertical line, the slope is undefined. Well, let's compare that to what happens. I'll leave that one over there for a moment. To what happens if we have a line going horizontally, like this. So here's our 2 points. Our slope, our rise, well, we're not going up anything. And then we're running 5. So 0 divided by 5, that's allowed to happen where 0 is in the numerator. So we have 0 as our slope. Okay, so in general, you have 4 different situations for slope. If your line is going upward, it's going to be positive. If your line looks like it's going downhill from left to right, it means your slope is going to be negative. If your line goes straight up and down, it is a vertical line, that means that your slope is undefined because your run is 0 and you can't divide by 0. And if it is a line, a horizontal line, then that means that your slope is 0. Okay, so those are the 4 situations that you could be in for these if they're graphed. Now, what happens if they're not graphed for us? Okay, so if you were to get something like this, So we want to find the slope between the points. Let's find this, or so, yeah, the slope between the points 2, 7, and negative 1, 1. Okay, we want to find the slope between those 2 points. Now, one way that you can go about this is you can actually graph those if you wanted. Okay, but if the numbers are kind of big or things like that, we may not want to do that. So in this case, we're going to use the slope formula where we're going to do y2 minus y1 over x2 minus x1. And in this case, it does not matter which one is y1 or y2 or x1 or x2 as long as it's staying consistent. So I'm just going to say that this is x1 and y1 because it's the first point, and this is x2 and y2 because it's the second point. Again, it doesn't matter. You could say that this was x2, y2, x1, y1. All right, so we're going to take y2 minus y1 and divide it by x2 minus x1, and then we're going to simplify that out. So 1 minus 7 is negative 6. Negative 1 minus 2 is a negative 3. Negative 6 divided by negative 3 is a positive 2. And so our slope between those two is 2. Okay, so let's look at one more here. What if we have the points negative 4, 6, and 2, negative 11? Okay, and again, we're finding the slope between those two. So negative 11 minus 6, we have to subtract the y's first. And then since we started with negative 11, we do need to start with a positive 2 here. And then we're subtracting a negative 4. So be really careful with that. So a negative 11 minus 6 is a negative 17. 2 minus a negative makes that be plus a positive. So that's going to be 6. And negative 17, 6 doesn't simplify, so you're going to leave it alone. Okay? So again, there's 3 different ways that you can kind of think about slope: rise over run, change in y over change in x, or using the slope formula y2 minus y1 over x2 minus x1. If you get confused with the formula, you can always plot the points and then count rise over run. That's kind of up to you. The graph could be kind of big. And then there's 4 different types of slopes that we have. Positive if it's going uphill, or if it looks like it's going uphill. Negative if it looks like it's going downhill. Undefined is where it's going to be a vertical line, and then a horizontal line is going to have a slope of 0. And that's it.